Hey y'all, today we are going to talk about rational versus irrational numbers. So let's take a few notes. First of all, let's write down rational and irrational. We need to know the difference between those two things. So the first thing that you should know is rational numbers are basically any kind of good old-fashioned number. It can be negatives. It can be regular numbers. So I'm just going to put your little hashtag. It can be any kind of number, like a regular whole number, fractions are rational, and also decimals are rational. Now, we're going to talk a little bit more about decimals being rational because there are some decimals that are irrational depending on how they look. So let's talk about irrational. An irrational number is a number that does not have any kind of formation about it. No repeating, they're just crazy. They go on and on and on in a different kind of weird pattern. No repeating, no pattern about them. They're just crazy numbers that just keep going forever. So an example of an irrational number would be pi. Pi goes on forever and ever and ever. So that's irrational. It doesn't stop. It doesn't terminate. Another example of irrational would be if you had a decimal, let's say you had 2.37824963 blah 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 blah, and it just keeps going in a different formation. There's no patternness about it at all. So let's go through a few examples together and see if we can figure this out. So a rational number is going to be a number that is your traditional whole numbers, your counting numbers, 1, 2, 3, 4, 5, 0, your negative numbers, -1, -2, -3, things like that. When you have fractions, rational numbers are any number that can be written as a fraction. So that's really important to make sure you know that. It's any number that can be written as a fraction. And an irrational number is a number that cannot be written as a fraction. So really, that is your distinguisher there. Can the number be written as a fraction or not? Pi cannot be written as a fraction. Random decimals that just continue and continue and continue without any kind of formation about them cannot be written as a fraction. So let's go through a few things, a few examples of rational numbers. So if I had the number 3, can the number 3 be written as a fraction? Yes, because that would be 3 over 1. So that would be rational because it can be written as a fraction. Now, what if I had the number 0.5? That's a decimal. Can that be written as a fraction? Yes. That is 5 over 10 because that's the 10th place, which is 1/2. So that is rational. Now, what if I had a repeating decimal? What if I had a repeating, like a 0.3 repeating? Do you know how to write repeating decimals as fractions? Anytime you have that bar over your decimal, you're going to determine what place that is. So this is the 10th place. So you're going to take this 3 and you're going to put it over a 9. That is the trick in writing repeating decimals as a fraction. And then this would reduce to 1/3, which is 0.3 repeating. That is rational. Now, talking about repeating decimals, Let's look at some that possibly are irrational. What if it looks like there's a pattern happening, but not really? So what if we have 0.323232? Well, what is repeating here? The 3 and the 2. So you're going to take both of those numbers. It's repeating in the tenths place and the hundredths place. So you would put that over 32 over 99. And if you're unsure, you can type that into your calculator to see, does that actually come out? I'm going to grab my calculator to show you. Does that actually come out to be that repeating decimal? And it does. Once you type it into your calculator, you'll see. Now notice I put it over 2 nines because both the tenths and the hundredths place were repeating. So I put it over 2 nines. If you had something that was repeating 3 times, like 1, 2, 3, 1, 2, 3, 1, 2, 3, it's repeating perfectly 3 times. So that trick would be to put it over 3 nines. And these are rational because repeating decimals are rational if they're repeating in a perfect pattern. Now, with me saying the word perfect pattern, let's talk about some things that are irrational as repeaters. So what if I had something, let's go ahead and label that all of these were rational. Okay, now let's talk about some that are irrational. So irrational are going to be crazy numbers that don't repeat in any type of pattern. So what if you had the number 0.23176843118. Notice that it just keeps going and it's continuing, and you're going to notice these little ... afterwards. That's kind of your indicator that it keeps going at a weird pattern. So that would be irrational. Irrational. Okay, so what if I had a decimal that was 0.123, 1123, 11123, 11123. Do you notice how it's continuing? It somewhat has a pattern, but it's not a definite pattern. This is kind of a crazy decimal. It just kind of keeps adding something to it every single time. Because it keeps changing, you're not going to be able to find a denominator to put underneath it. So this would be irrational. Because it keeps changing and adding a number, you won't have a denominator where you can put that number under it. Whereas up here, the repeater was identical, so we were able to put it over our denominator. Our denominator was able to be 99 and then 999. Okay, so at the top, you have rational and irrational, and the big indicator of irrational also would be pi, because it just keeps going crazy. Now, these are irrational. Irrational, because they don't have a formation about them. They do not repeat in a perfect pattern. They keep repeating in a different kind of pattern, or they're non-terminating. This is a non-terminating. It does not stop. That number just keeps going and going and going. So what if I have just like 0.38? That terminates. That can be written as a fraction. 38 over 100, because that's the hundredths place. So 38 over 100, because that's 0.38. Now, what if you had, let's bump down here and add a few more rationals down here. Let's add another rational section to talk about. What if you just had 0.7? Well, that's a terminating. It stops. The decimal does not repeat. It's terminating. It stops. It's one place, a tenths place, so 7 over 10. Rational. Okay, let's talk about some fractions. So what if we have the fraction 2/4? That's rational because it is written as a fraction? That would be 0.5. Rational. Good. What if we have 3/7? Now, if you're unsure what the decimal would be, you can type it into your calculator. 3 divided by 7. Now, notice that this decimal looks like it's just kind of different. There's no repeaters there. However, was this a fraction to begin with? Yes, it was. So it is automatically rational. Okay, so let's try another one. What if we have -8? That's rational because negative numbers are written as fractions. This would be -8/1. So that is rational. So the trick here is basically, if it's rational, it can be written as a fraction. If it's irrational, it can not be written as a fraction. I hope this helps y'all. Have a great day. Bye.